9th Physics Chapter Forces in Fluids ആണ് ഇവിടെ ഡിസ്കസ് ചെയ്യുന്നത്. ഇവിടെ ഫസ്റ്റ് തന്നെ ഒരു ഫിഗർ കൊടുത്തിട്ടുണ്ട്, ഫോഴ്സസ് ഇൻ ഫ്ലൂയിഡ്സ്. ഇവിടെ നമുക്ക് ഒരു ഷിപ്പിന്റെ ചിത്രം കാണാം, അതേപോലെ ബ്ലേഡ് വാട്ടർ സർഫസിൽ നിൽക്കുന്ന ചിത്രവും കാണാം. Have you ever thought of this question? Why does a ship remain afloat on water? Is it due to the same reason that a razor blade also floats on water? But then, why is it not possible for all substances to float on water? We know that each and every substance are not flowing on water. Some sink into the water. What is the reason behind all these? This we are going to study in this chapter.
See what happens when a bottle partially filled with liquid placed above water surface. Place a tightly closed plastic bottle in water. What do you observe? Place an air-filled balloon over the surface of water. What happens? Can water exert force? Observe. A body situated in a liquid experiences two forces. One, the weight of the body acting downwards. Two, the buoyancy acting upwards on the body.
Now, here is an experiment. Take water in a bucket. Place a tightly closed empty plastic bottle on it. Then what will you observe? We can see that the plastic bottle will float on the surface of water. We can see that the empty plastic bottle will float on the surface of water. Now, using your hand, try to immerse the plastic bottle to the bottom of the bucket. If we push the plastic bottle to the bottom of the bucket, then what can we see? We can see that the plastic bottle returns to the top surface. Why does it rise to the surface of water? Why does this bottle rise to the surface of water? Shouldn't the heavy substances be going down? We have seen that many heavy substances are going down the water, or they sink into the water. Why did the bottle experience an upward force greater than its weight? We know that the weight is always acting downwards. The weight is the attraction by the earth towards its center. So every body is attracted towards the center of the earth. Thus, the weight is the force acting downwards. Now, in order to come to the top surface, the weight of this bottle should be less than the upward force. Will it be possible for liquids to exert an upward force? Then who exerted the upward force on the bottle? Here is the liquid in the bucket. Therefore, only chance is that the water contained in the bucket acts an upward force on this bottle, and which is greater than weight. Now, the second situation is given here. Let us consider another situation. When an immersed object is lifted up within water, its weight appears to be less than that in air. What is the meaning? That is, the boy is taking this stone or brick from the water. When the brick is inside the water, he feels very less weight or he takes this with easiness. When the brick is outside the water, that means when the brick is in air, he is very tough to hold it. That is, it is very heavy for him. What is the reason? The same boy, the same brick, but one inside the water he feels less weight and outside the water he feels more weight. What is the reason for this increase in? This is because there is a buoyant force, or the buoyancy. It is also known as buoyancy. That is, inside the liquid or inside the water exerts an upward force on this brick or on this object. This upward force is named as buoyancy. Now, it is exerted not only by the liquids, that is, it is exerted not only by the liquids but also by gases. It is exerted, that is, the buoyancy is exerted not only by liquids but also by gases. That is, liquids and gases can act or can exert this force. Liquids and gases are generally called fluids. Now, what are fluids? Liquids and gases together are generally called fluids. Fluids means it includes both liquids and gases. Both liquids and gases are collectively called as fluids. Now, there are two types of forces acting on this body. A body situated in liquid experiences two forces. The two forces are the weight of the body acting downwards and the buoyancy acting upwards on the body. Thus, we realize that there are two forces acting on this body. One is a downward force and other is an upward force. The downward force is due to its weight and the upward force is by the liquid, and the upward force is termed as buoyancy and the downward force is its weight. Understand? A body situated in liquid experiences two forces. The weight of the body acting downwards and the buoyancy acting upwards on the body. Now, let us define what is buoyancy. When a body is immersed completely or partially in a fluid, the fluid exerts an upward force on the body. This force is known as buoyancy. Now, you have to study what is buoyancy. Buoyancy is defined as the upward force which is exerted on the body when the body is placed in a liquid or gas, that is, in a fluid. When the body is immersed completely or partially, either it is completely immersed in the fluid or it is partially immersed in the fluid exerts an upward force on the body. This force is known as buoyancy. Tabulate some situations in your daily life in which you have experienced buoyancy in liquids and gases. Here is an example given. That is, in our daily life, there are many situations where we experience buoyancy. A hydrogen-filled balloon rises in the air. The hydrogen-filled balloon rises in the air. This is due to the upward force exerted by air on the balloon. Now, we have to fill this. That is, we have to say another example where we experience buoyancy. We can say the case of ship floating in the sea, or the aeroplane flying in air, How to measure buoyancy? How to measure buoyancy? How to measure buoyancy? Take a piece of stone and a piece of metal of almost the same size. Take a piece of stone and a piece of metal of almost the same size. Find out the weight of each in air using a spring balance calibrated in Newton. That means we can use this spring balance. This apparatus is called spring balance. And here the calibration is done in Newton. That is, the weight is expressed in Newton. Such a spring balance is used to find the weight of a body in air or in water. To find the weight of this is the stone. Therefore, the stone's weight in air is measured like this, and by dipping this stone into water, we get the reading or the weight corresponding to the weight in liquid.
Spring balance is used for measuring weight. This is a small stone piece. I am tying this on this spring balance. The weight of the stone is 1.1 Newton. Now the teacher weighs it with a spring balance. The weight of the stone is 1.1 Newton. That is, the force exerted by the earth on the stone is 1.1 Newton. That is the weight of the stone. Now he immerses the stone in water. When he weighs it in water, the reading of the spring balance decreases to 0.55 Newton. When a body is immersed completely or partially in a liquid, the liquid exerts an upward force on the body. This force is the buoyancy. Now you know the reason why when a bucket is immersed in water in the well, you feel some loss of weight. When you pull the bucket upwards, you feel more weight. Why? When the bucket was immersed in water, water exerts an upward force. That is called buoyancy. When the bucket was in the air, the force exerted by the earth on the bucket is greater than the buoyancy force exerted by the water on the bucket. Therefore, we feel more weight in the air than in water. Now the teacher takes a metallic piece and weighs it. The weight of the metallic piece in the air is 2.1 Newton. He immersed it in water and weighed. The weight of the metallic block in water is 1.4 Newton. So the loss of weight of metallic block in water is 2.1 Newton minus 1.4 Newton. That is 0.7 Newton. Now he is salting the water. Now the teacher immerses the metallic block in the salt water. The weight of the metallic block in the salt water is 1.3 Newton. The buoyancy in the salt water is 2.1 Newton minus 1.3 Newton, that is 0.8 Newton. Loss of weight in water is 0.7 Newton. Loss of weight in salt water is 0.8 Newton. But the mass is the same. Now the teacher is going to immerse the metallic block in kerosene. He fills the vessel with some kerosene. He immerses the metallic block now in kerosene. The weight of metallic block in kerosene is 1.6 Newton. The weight of metallic block in air was 2.1 Newton. The weight loss in kerosene is 2.1 Newton minus 1.6 Newton. So the loss of weight in kerosene is 0.5 Newton. So the buoyancy in kerosene is 0.5 Newton. The weight of the metallic block in salt water was 1.3 Newton. The weight of metallic block in kerosene is 1.6 Newton.
Now we have to write these values in the columns. That is the weight of stone. Say it is 10 Newton in air. Now what happens to the weight when it is dipped in liquid or water? Inside water, its weight will be decreased or it will feel a weightlessness. Therefore, here the value will be less, somewhat less. That is, if it is 8 Newton, then what is its loss of weight? Loss of weight means it has lost a weight equal to the weight in air and the weight in water. That is, it has loss of weight equal to W1 minus W2, where W1 is the weight in air and W2 is the weight in water. If we know the weight of the stone in air and the weight in water, then we can find its loss of weight by simply subtracting its weights. Similarly, we take a piece of metal, any metal piece, and find its weight in air and its weight in water. Now we can see that the buoyancy is the same as the loss of weight in water. Thus we can measure buoyancy as the difference in weights in air and water. That is, the loss of weight will be equal to what? The buoyancy, or the buoyancy and its loss of weight are equal. This means that in order to calculate the buoyancy experienced by a substance immersed in a fluid, it is enough to find out the loss of weight of the substance in that fluid. This should be noted. That is, we can measure buoyancy. For that, we have to find its weight in air and the weight in fluid, then subtract from the weight in air. Thus, we get the buoyancy experienced by the substance. Now, does the same substance experience the same buoyancy in all liquids? That means if the stone is dipped in water, it has certain buoyancy, and if the stone is dipped in oil, it has certain other buoyancy. Then is the two values are equal, or will all the values of the same stone in different liquids are equal? That is to be found out. Thus we move to the second topic, factors that influence buoyancy. Now, the factors that influence buoyancy. Let us find what are the factors that influence buoyancy. Here, 3 beakers are given with water, saline water, kerosene. These are different in their densities. That is, we know that saline water has very high density. Water has density in between saline water and kerosene has least density. Now we have to find the buoyancy in water, in saline water and in kerosene. Now we can see that buoyancy is greater in saline water. Here we can also compare the densities. The densities are given here. Water 1000, kerosene 810 kilogram per meter cube, saline water 1025 kilogram per meter cube. Thus we see that the buoyancy is higher in a liquid which has greater density. Thus, we arrive at the conclusion that the density of a liquid is a factor that influences the buoyancy of a body in that liquid. Thus, we can see that density is a factor which influences the buoyancy. The buoyancy is influenced by the density of liquid, and also we find that when the density is greater, buoyancy will also be greater. Buoyancy increases with increase in density. Now there is a question given. Does a ship enters a freshwater lake from the ocean sink or rise more? Justify your answer. That is, if a ship enters a freshwater lake, we know that the freshwater lake has a liquid, that is the water in the freshwater lake has less density compared to ocean which has greater density, which contains salt water. Therefore, we know that in ocean the buoyancy will be greater and in freshwater buoyancy will be somewhat lesser. So when the ship enters a freshwater lake from ocean, it will sink more because the buoyancy is less in freshwater lake. Now there is another factor on which buoyancy depends. For that, here two blocks are given, iron block and copper block. These two have equal weight. That is, two blocks of equal weight. Weights are equal, but the materials are different. Also, their size or their area are different. Their volume is different. Now, we can find the buoyancy of copper block by finding its weight in air and its weight in water. By subtracting these two values, we get the buoyancy of copper block. Now we have to find the buoyancy of iron block. To find this, we have to take its weight in air and then we have to dip the iron block in water and then find its weight. Then we have to find its buoyancy. To calculate buoyancy, we can subtract weight in air and weight in water, or weight in air minus weight in water will give our iron blocks buoyancy. Now, the mass of copper and iron blocks are the same because their weights are the same. But are their volumes same? This is very important. That is, the mass of the copper and iron blocks are same. Both are same because their weights are same. But their volumes are not same. This has iron block has more volume and copper block has less volume. Now you have realized that the buoyancy acting on a body depends on its volume also. That is, there are two factors on which buoyancy depends. Buoyancy depends. That is, first one is density and the other one is its volume. That is, when density of the liquid is greater, then it experiences or it can exert more buoyant force on a body. If a material or an object has more volume, then it will experience more buoyancy, because its volume is another factor which depends on buoyancy. In short, we can say that the two factors which influence buoyancy are density of the liquid and volume of the object.